Let's draw our 6x6 board and record the values of all the squares. The value of each square is the sum of the row and the column, so we'll fill in all of these values. The problem asks for the average score, which is the sum of all the scores divided by the number of possible configurations. So we'll start by finding n here in the denominator. This is the total number of arrangements. When placing our 6 rooks, we can do this column by column so that no 2 rooks share a row or a column. Placing a rook in column 1, we have 6 choices. Placing a rook in column 2 can't share the same row as the rook in column 1, so that leaves 5 choices for placing a rook in column 2, and so on in column 3, 4, 5, and 6. So the denominator of our average is 6 factorial. For any arrangement, the score is the value of the rook with the smallest value. That means our score is going to be greater than or equal to 2, the smallest value square on our board. Let's consider how many arrangements there are if the score is instead greater than or equal to 3. This means we have no rooks in our lower left square at 1, 1. Placing our rooks column by column, starting with column number 1, we have 5 choices for where we can put a rook in the first column. Without loss of generality, let's say we place a rook here in row 4 with a value of 5. In column 2, we can place a rook anywhere except in row 4. This gives us 5 choices for column 2. Let's say we place a rook here in row 2. Placing a rook now in column 3, we have 1, 2, 3, 4 choices, which leaves 3 choices to place a rook here in column 4, and so on. This gives us 600 possible arrangements of rooks that will yield a score greater than or equal to 3. To find the number of arrangements where the score is equal to 2, we can take the number of arrangements where the score is greater than or equal to 2 and subtract the number of arrangements where the score is greater than or equal to 3. Greater than or equal to 2, that's 720. Greater than or equal to 3, we have 600 arrangements. This means there are 120 possible arrangements where the score of the 6 rooks is equal to 2. We'll keep calculating this way. Let's find the number of arrangements where the score is greater than or equal to 4. When we place a rook in the first column, it can't be in rows 1 or 2. So we have 4 choices for our first rook in column 1. In column 2, we can't place a rook in row 1, and we can't place a rook in any row occupied by a rook in column 1. So for example, if our first rook was in row 5, we can't place a rook here or here, which leaves us with 4 choices to place a rook in column 2. Let's say it's this one. Now in column 3, if we want to place a rook, we can't place it here in row 3 or in row 5. That leaves us 4 squares in column 3. Let's place a rook over here. This leaves us 3 choices for column 4, 2 choices for column 5, and 1 choice for the last column. This gives us 384 arrangements of 6 rooks that produce a score greater than or equal to 4. Calculating the number of arrangements where the score is equal to 3, we'll take the number of arrangements where the score is greater than or equal to 3 and subtract the number of arrangements where the score is greater than or equal to 4. That's 600 minus 384, or 216 arrangements that produce a score equal to 3. We'll calculate the number of arrangements that produce a score greater than or equal to 5. In the first column, we're looking at these 3 top rows. So we have 3 choices to place a rook in column 1. We'll have 3 choices as well in column 2 and 3 and 4. Column 5 will have 2 choices and 1 choice in column 6. This is 162 arrangements with a score of greater than or equal to 5. Calculating the number of arrangements where the score is equal to 4. This is the number of arrangements where the score is greater than or equal to 4, subtracting the number of arrangements where the score is greater than or equal to 5. This is 384, and we'll subtract 162. For a score greater than or equal to 6, the number of arrangements, again going column by column, we'll have 2 choices for column number 1, leaving 2 choices for column number 2, and so on. This is 32 arrangements with a score greater than or equal to 6. And we'll subtract to find the number of arrangements where the score is equal to 5. This is going to be 162, and we'll subtract 32. Now for scores that are greater than or equal to 7, we'll have 1 choice for placing a rook in column 1, and so on for all the remaining columns. So that's just one arrangement. This arrangement has a score equal to 7, and it's the only arrangement that does. It's not possible to have a score greater than or equal to 8. You can see that by trying to choose a rook in the first column. So we can stop here. We should also find the number of arrangements that produce a score equal to 6. That's going to be these 32 arrangements minus the one arrangement that produces a score equal to 7. Now we're going to calculate our average. To calculate the average, we're going to find the sum of all the scores of all possible arrangements of 6 rooks on the board, divided by the number of possible arrangements. We already know that there are 720 arrangements where no 2 rooks share a column or a row. We have 120 arrangements where the score is 2, so a score of 2 will occur 120 times in our numerator. We have 216 arrangements where the score is equal to 3. A score of 4 will appear 222 times in our numerator. Score of 5 will occur 130 times, and a score of 6 will occur 31 times, and a score of 7 occurs once. Adding the numerator and simplifying gives us a fraction of 291 over 80. The problem asks for the sum of P and Q, and our answer is 371. If you'd like me to solve any other math contest problems, please leave them in the comments.